How to find the equation of a line given 2 points. First problem, find the equation of the line containing the 2 points, then graph the line. We have the coordinate pairs 1, 7 and 4, -2. And for this we're going to use 2 formulas. First, the formula to find the slope of a line, which is going to be m, or slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is simply the slope equals the change in y divided by the change in x. And in conjunction with the slope formula, we're going to use another formula, which is the slope-intercept form equation of a line, y equals mx plus b. The m referring to the slope, and the b for beginning being the y-intercept, or starting point on the y-axis. And for this we're going to use what I think is really a graphical organizer form of the slope formula, and this is called a 3-column process chart. And for an input of 1 we have an output of 7 for our first point, and for our second point we have an input of 4 and an output of -2. And to find the change in y divided by the change in x, we take -2 minus 7, that's our change in y, which is -9, divided by our change in x, which is 4 minus 1, or 3. Next, our slope is going to be our change in y divided by our change in x, which is -9 over 3, which simplifies to -3. So there we have our slope. And so now we're going to try and use our process to see if this works using the slope-intercept form of an equation. We have y equals m, and m we calculated to be -3. X, in this case, is the point 1, plus b. And b we do not know yet, but we have an equation that we can use to solve for b. And writing this equation, we have 1 times -3, we have -3 plus b is equal to 7. And solving for b, if we add 3 to both sides of the equation, we have b equals 7 plus 3, which is 10. And so now, having found the y-intercept, we're going to use the second point to check to see if this works. And to do this, we take this new input value 4 times our slope of -3 and add to it 10 and see if that equals 2. Well, erasing and working below, we have 4 times -3 is -12, plus 10 equals -2, -12 plus 10 equals -2, and -2 equals -2, check. So that second point checks. Now we're going to graph the line and see if the points match up on the line. And first of all, to graph this line that we've calculated, which is going to be y equals -3, or slope m, x plus 10. First of all, we go up to 10. We take our -3 is going to be our rise over 1. And so we go down, rise over run, our rise being -3, down 3, and over 1. And I'm going to go ahead and make some extension points here to help with the drawing. And so we draw this line here. Okay, kind of a rough line, but okay. That's going to have to do. Limitations of hand drawing of lines. Now we're going to take our points and see if these points reside on this line. We have the point 1, 7, and 1, 7 is right on the line. Check. Sometimes it's the second point that will mess us up. So 4, -2. So we go to over 4 to the right, down 2. So 4, -2 resides on the line. So this graph checks our equation. So now we're certain that our equation of the line containing the 2 points is y equals negative 3x plus 10. Okay, we're going to go to another problem. I'm going to leave my 3-column process chart right here. Alright, this next one is find the equation of the line consistent with the 2 points, then graph the line. And we have this f of negative 2 equals 6 and f of 1 equals 4. And these points are simply written down in a kind of a function notation form that if we plug negative 2 or an x value into this function, we get as an output 6. And likewise, if we plug in 1 to this function, we're going to get an output of 4. So again, using our slope formula, we have the change in y, 4 minus 6 is negative 2, and 1 minus negative 2 is 3. Okay, integer arithmetic, very important. And so our m, our slope, is going to be the change in y divided by the change in x, which is negative 2/3. Now, testing out, trying out, and getting our y-intercept, we have our slope, mx, so we have negative 2/3 times negative 2x plus b is equal to 6. Now we're going to bring down this equation and work it out. Okay, negative 2 times negative 2 is 4, so we have 4/3 plus b is equal to 6. So now we're going to subtract 4/3 from both sides of the equation. And we have cancellation here, so b is equal to, well, how many thirds do we have in 6? We have a denominator of 3 here. To get a common denominator, what do we do to get how many thirds we have in 6? Well, we just take 6 times 3, so we have 18 thirds, which is the same as 6, minus 4/3. And 18 thirds minus 4/3, 18 minus 4 is 14. And we have thirds here, so 14/3 is our calculated value for b. Now, for what that number really is, 15/3 would be 5, and so as a mixed number, 4 2/3 would be our mixed number form of b. And so according to what we've found so far, let's go ahead and check this out. Second point first. Okay, we plug in our negative 2/3 times 1 plus b plus 14/3. See if that checks out. Well, what we have is negative 2/3. That's going to be negative 2/3 times 1 plus 14/3 equals 4. That negative 2 plus 14 is going to be 12/3 equals 4. 12 divided by 3 is 4. So we have 4 equals 4. Check. So this point checks. Now we're going to plot the points and see if these 2 points find themselves in the line. Our y-intercept is going to be 14/3, which is going to be 4 2/3, 1, 2, 3, 4 2/3, so about right there. Our rise over run, well, we have negative 2 is our rise, so we go down 2, and our run is 3, and then we have a line. This will be our line. We hope it's going to be y equals negative 2/3 x plus 14/3. And we check our points to see if they're on line. Negative 2, 6, negative 2, 6, that happens to be on line negative 2, 6. And then lastly 1, 4, 1, 4, that resides on the line. So we've checked using the line. So we are certain that our equation for this line is going to be y equals negative 2/3 x plus 14/3. So this is how to use the slope formula and the slope-intercept form of the equation of the line using this graphical this graphic organizer form to find these equations. I hope this has been helpful. Thanks for viewing.